Welcome to the MecSoft Student Project Series, where you can find real students in academia using MecSoft products in an educational setting. Today we'll see a composite bicycle helmet project created with the help of RhinoCam by student Wyatt Jeffries at IYRS School of Technology and Trades in Newport, Rhode Island. IYRS School of Technology and Trades is a nonprofit post-secondary experimental learning school located in Newport, Rhode Island. The school offers education and training programs for craftspeople, artists, fixers, technicians, thinkers, problem solvers, and creatives. The school is located on Aquidneck Island, whose yacht-filled harbor once hosted the America's Cup, a renowned annual sailing regatta for many years. The school's alumni are rapidly employed into the local shipbuilding industry, which helps make Newport one of the most popular lifestyle and tourist destinations on the New England seacoast. Composites technology. Composites are broadly defined as materials in which a binding agent, such as resin, is reinforced with a strengthening material, such as glass or carbon fibers, within a mold. Kelsey Britton is the Composites Technology Program Manager and instructor and considers shipbuilding to be more of a way of life rather than a job. Her mother taught Kelsey how to sail as a child. Her brother is a ferry boat captain in New London, Connecticut, and her father is a career marine mechanic and manager. Kelsey started her career in hospitality, doing everything from bussing tables to managing entire restaurants. Soon, however, the love of the boat-building trade urged her back home, where she enrolled and excelled in the school's yacht restoration program. Kelsey made such a positive impression on the staff that in no short order she was offered and accepted a full-time position to teach at the school she loves. We recently sat down with Kelsey to discuss her use of RhinoCam as part of her curriculum in her Composites Technology class. Here is some of what Kelsey Britton, Composites Program Manager and Instructor at IYRS School of Technology and Trades, had to say about her RhinoCam.
A lot of the stuff on MecSoft website, like all the support on all the blog posts and stuff, has been really helpful. I do like how every time I go back into it and there's more information and there's more, like, if you hover over this, a little bubble pops up, and I feel like every semester there's more access to support, and that's huge for me.
Thanks, Kelsey. The Bicycle Helmet Project. As a contribution to their final grade, each student gets to choose a composite project. In this project, student Wyatt Jeffries manufactures a bicycle helmet using composite technology materials and techniques. The helmet design was downloaded and loaded into Rhino 3D, where the NURB surfaces were used to design a composite mold. The mold was then used to create the resin and fiberglass composite layup for the outer shell. The mold was also used as a fixture to machine the helmet's foam inserts. The 3D model of the helmet is shown here in Rhino. For this project, right and left side mold halves of the outer helmet shell were designed in Rhino. Only the outer shell needs to be represented by the mold. Shown here on the left is the right side mold cavity block designed in Rhino. RhinoCam is then used to create the Toolpath strategies and the G-code needed to run the school's Freedom Patriot 3-axis CNC router. The 4 locators are used to mate with the left side cavity. On the right, we see a 2.5-axis facing operation to level the parting plane, and a 3-axis pocketing operation for the 4 locators. Machining the mold cavities. Here on the left, we see the cut material simulation and the in-process stock results of a 3-axis horizontal roughing toolpath strategy, also referred to as Z-level roughing. Using a 12.7 millimeter diameter flat end mill, this strategy is used to clear out excess material from the cavity. Cutting parameters include a 0.6 millimeter stock allowance, an offset cut pattern, and a mixed cut direction. The cutting tool works its way out from the center of the cavity at a 40% step-over distance. Each cut level begins with a 10-degree path entry and removes material at a depth of 50% of the cutting tool's diameter. Arc fitting in each XY plane is also performed. This both minimizes the amount of G-code required and maximizes accuracy. On the right, we see the results of a 3-axis horizontal finishing toolpath strategy using a 6.35 millimeter diameter ball mill. This strategy is also referred to as Z-level finishing. Cut parameters include a stock allowance of 0, a climb cut direction, and a step down of 1 millimeter between the Z levels. In this strategy, the steep side areas of the cavity are cut with the radius and sides of the tool. In the bottom flatter areas, 3-axis parallel finishing is used, which adds additional cutting paths utilizing the tip of the ball mill. Mold preparation and layup. Each side cavity block is made up of 6 levels of 10 millimeter thick MDF material. The machined cavities are shown here on the left are then visually checked, hand sanded, and then clamped together using the locator pins for alignment. To prepare the cavity for composite layup, 4 to 5 coats of epoxy resin are applied. Then up to 600 grit sanding, buffing, and polishing. On the right, we see the fiberglass composite material placed into the cavity. The same cavity mold is also used as a fixture to machine the inner foam inserts of the helmet. Here on the left, we see Wyatt giving the mold cavity some last-minute preparation. On the right, Wyatt presents the completed composite helmet. Great job, Wyatt. More about IYRS. IYRS School of Technology and Trades, located in Newport, Rhode Island, offers marine industry classes on composites technology, marine systems, boat building and restoration, as well as digital modeling and fabrication. To learn more about the IYRS programs, we invite you to visit them online at iyrs.edu, as well as on Facebook, Twitter, and Instagram. RhinoCam is available in 5 configurations: Express, Standard, Expert, Professional, and Premium. The parts shown here were programmed using the Professional configuration. Here are some additional details about each of the available configurations. For the complete features list, we invite you to visit the RhinoCam product page. See the link in the description below to download your RhinoCam today. We want to extend a special thanks to Kelsey Britton and the IYRS School of Technology and Trades for allowing us to showcase their work. This video was brought to you by MecSoft Corporation, your CAM partner.